Here's the refraction lab, and what we're going to try to calculate this time is going to be the index of refraction of water. And if you remember last time, when we had our laser, it was going through light first, and then it was going through a glassy material second, and so it was refracting on the inside of that. What we're doing in this lab is we're going to be going through the watery material first, and then we're going to exit coming into the air. So there's going to be a little bit of changes in this, and we're going to be trying to calculate what the index of refraction is. Now, this is going to be slightly different than the instructions on your handout, but what we have here is I'm going to be coming in and shining in the laser from a particular angle, and we're going to be seeing what is going to be that refracted angle. So what we're doing is we have the compass, as you can see. We have a semicircular Petri plate that has some water on the inside. You can see the water sloshing there. And we're going to be coming first, it's going to be traveling through the watery material. Yes, it's first coming from the air, but this is a curved plate, so it's going to be allowing the light to enter in straight, as if this was completely flat. So if I'm coming in from a 30-degree angle, you can see that the light is not really going to be bent when it comes in, but it is going to be bent when it comes out into the air. And so that's what we're going to be calculating. So I'm going to be shining it in at a 30-degree angle. We're going to be seeing what angle is it being refracted at as it comes out. And we're also going to do the same thing for a 45-degree angle. So coming in at a 30-degree angle, I'm going to see if I can do this as best as I can. I want to shine it at a 30-degree and making sure that it's also traveling through the very center of my protractor. I don't want to be going off at an angle because I want to be seeing what angle is it being refracted at coming from the very, very center. So I can see I'm coming right through the 30, it's going right through the center, and it's coming out at about, let's see, 39. Remember that this is the normal going up and down like this, and so we're measuring the angle from here, which is 0, off in this direction. So again, if I'm coming in at 30, coming in, going through the center, actually we're going to say that's 40. So it's coming out at a 40-degree angle, and we'll record that. And now we're going to be coming in at a 45-degree angle, going through the center again. And the 45 is coming out at about 60. To 63. We'll just say 63 degrees. So I'm going to turn the lights on and we can go ahead and go through these calculations using those two angles. So I'm going to go ahead and move this away and bring in this lab. So remember our angle of incidence, this is traveling through the water first, and the refracted angle is going into air. So it's going from a denser to a less dense environment. If you remember, if it's going into a denser, it's bent toward the normal. When it's going into a less optically dense, it's going to be bending away from the normal. So at a 30-degree angle, we had a refraction into the air of about 40 degrees. And with a 45-degree angle, it was about 63 degrees. So we're going to be using Snell's law. We're going to be rearranging. So we have the index of refraction for the incident ray, which is actually the water. That's what we're trying to solve in this case. We're not trying to find the refracted material because we know that this is going to be air. So we're trying to solve for the index of refraction of the water. What is it that it's first passing through? Times the sine of the incident angle is going to be equal to the index of refraction for the refracted material times the sine of theta for the refracted material. Again, here's our water, this is the air. We're trying to solve for this. So we're going to divide both sides by the sine of the incident angle divided by the sine of the incident angle. So the index of refraction for air is 1.0. That actually would cancel. And so it's the, oops, we have to change this. This is the incident angle, this is the refracted angle. So we're going to do the sine of the refracted angle, which is 40. So we're going to have the sine of 40 degrees, enter, divided by the sine of 30 degrees. And that would give us about 1.29 in 3 digits. 1.29. So we're going to do the same thing. Here's the refracted angle. Here is the incident angle. Remember, it came through the water first and then came into the air. So we're doing the refracted angle, so it's going to be a sine of 63 divided by the sine of 45. That gives us about 1.26. Those are pretty close, so we're going to average these two together. 1.29 plus 1.26 divided by 2. That gives us about 1.28 for an average index of refraction of water. The actual index of refraction is equal to 1.33. So we were pretty close.